Hi, good afternoon. My name is Maxwell, Sengiang, Anak, Liban.
My name is Mohamad and Danial.
And my name is MEGAT AZIZ, and we are from Group E1. And for today, we will be presenting about applied maximum and minimum in differentiation. First of all, what is differentiation?
The meaning of differentiation in terms of mathematics is to find the derivative or the rate of change of an equation.
In simple terms, we can find a tangent of a function using differentiation. Typically, you'll see a boring graph of a function and you have to solve it. But is there anything more significant in differentiation than just graphs? Well, in fact, there is. For instance, you could find the speed of a duck swimming towards its mother, or to find the rate of change of a balloon's deflation when its radius is at a certain length. Other than that, there are also several other applications for differentiation. As I've mentioned earlier, it is rate of change. For example, I could calculate the exact camera angle needed when a rocket is flying above the launch pad at a certain distance. So today, our group member Max will explain a question about applied maximum and minimum.
A tank with a rectangular base and rectangular sides is open at the top. It is to be constructed so that its width is 4 meters and its volume is 36 cubic meters. If building the tank costs $10 per meter square for the base and $5 per meter square for the sides, what is the cost of the least expensive tank and what are its dimensions? So here, for me, to make we understand the question better, we should draw a diagram for the question. So here it say the tank has a rectangular base and rectangular sides. So here the plane and it has open at the top. So I already divide the question into a few parts, which is problem statement, understanding the problem, objective, and lastly is the problem solution. So for the first part is the problem statement. Here the tank with a rectangular base and rectangular sides with open at top. Make sure the diagram that you draw has a open top, not closed, and all the planes that used to make the tank have its own cost. The question is, what is the cost of the least expensive tank and what are its dimensions? We move to the next part, how to understanding the problem. It given that the width is 4 meters and the volume is 36 cubic meters. Also, it given that the cost for the base and the sides. So here the cost for the base and here the cost for the sides. So I will let the length of the tank will equal to x and the height will equal to y. We will make one equation later. So what is the objective for the question is we need to find the smallest dimension for the plane of the tank, so that the price of making the tank is the least expensive. So here the keyword for the question. To make it clear, what is the smallest dimension to minimize the cost of the tank? So here the solution. Given that the cost for the base is 10, the cost for the side is 5. The volume is 36 per meter cubic, which equivalent to 4xy. How do I get 4xy? Because x times by 4 times by y equal to volume. So here we get one equation, and remember we need to express the equation only in one term. So here express x in term of y. So here the final equation. So x is equal to 9 over y. Then we need to find the formula for the cost for the tank. In the equation said that the side will cost for 5. Here there are only 2 or 4 sides of the planes, which is front, back, right, and left. And for the base, only one. This is for the base. Why? Because at the top the tank is open. There are no need to pay for it. So here I will get this equation. Why do I get 2xy? Because there are two planes for x multiplied by y, which is front and back, then plus by right and left plane, which is equal to 8y times by 5, and lastly is for the base is 4x times by 10. So the last equation we will get is 10xy plus 40y plus 40x. Remember that we need to substitute the value of x into this equation. So here the result, when we substitute the value of x, we will get 90 plus 40y plus 36 over y. Then how to know we will get the least expensive of making the tank? We need to differentiate the cost so that we will get a critical point. The price is the lowest. So here is dc over dy. How we get 40 minus by 36 over y square? Because 90 we differentiate will get 0, 40y we differentiate will equal to 40, and 36 over y we need to bring y into the top and we'll get y to the power of negative 1, and we differentiate it, we'll get 36y to the power of negative 2, and bring the y into the bottom of the equation, we will get 36 over y square. And then we need to find the value of y. So how to find the value of y? We need to assume that dc over dy is equal to 0. Then at last we will get y is equal to plus minus 3. Remember that we need to take the positive value, because for the volume there are no such thing for the negative value. So y equal to 3 here. Then the next step is we will find for the cost. Just substitute y into this equation. So here we will get $330 for the cost. And for the last part, we need to find the dimension for the tank. So when y is equal to 3, then x is equal to 3 meter. So here the dimension of the tank: 3 for the length, 4 for the width, and 3 for the height. So we can conclude that the cost of the least expensive tank is 330, and the dimension that will minimize the cost of the tank is 3 meter by length, 4 meter by width, and 3 meter by height. So that's all from me. So we can conclude that apply maximum and minimum and differentiation can help us solve various types of problems in our daily life. All it takes is a little brain power and a calculator, and our life will be a lot simpler. So bye, thank you, see you again.